Another application of systems of equations has to do with motion. And these particular questions deal with the speed of a plane and the speed of wind, flying from one location to another. So the two pieces of information I'm trying to find are the speed of the plane, which I'm going to call P, and the speed of the wind, which I'm going to call W. Makes it a little bit easier. You could use X and Y if that makes you feel better. The other thing I know about this is that distance equals rate times time. So what I'm going to do is I'm going to say from Atlanta to Miami, the distance is 660 miles. The rate is the tricky part, so I'll come back to that. The time is 1.2 hours. Let's talk about the rate. From Atlanta to Miami, I'm traveling with a tailwind. So if P is the speed of the plane and W is the speed of the wind, that means if I add those two together, that would be the speed of the plane with the wind helping us out. So this is P plus W. Now, when I go from Miami back to Atlanta, I'm going to still go 660 miles. But now my rate is the speed of the plane minus the speed of the wind because I've got wind basically slowing me down. So my speed, my rate will decrease. And that's why it takes a little bit longer, 1.5. Now, I can solve this pretty easily by taking 1.2. I'm going to divide, so I've got 660 equals P plus W times 1.2. Now most people would distribute that 1.2, but that's actually going to make it more difficult. So I'm going to divide by 1.2 on each side, and that's going to give me 550 equals P plus W. The 1.2 went away. Using that same process, if I divide by 1.5 on my second equation, I get 440 equals P minus W. And the reason that works so well is now I've got two equations that are in the same form, and I can add them together, and that will give me 990 equals 2P, because P plus P is 2P, and my W's cancel out because I'm solving by elimination. So when I divide by 2, I get 495 equals P. P represented the speed of the plane, so the plane is going 495 miles per hour. To find the speed of the wind, I would plug it back into this first equation. So 550 equals 495 plus the speed of the wind. If I subtract the 495, I find out that 55 equals W. And again, I would write a sentence that said the speed of the plane is 495 miles per hour and the speed of the wind is 55 miles per hour. Very similar question on this one. Again, distance of 1200 equals the rate with a tailwind, which would be P plus W, times the time of 2 hours. And on the way back, the distance remains the same, P minus W, and 2.5 hours. Again, I would divide by 2, which would give me 600 equals P plus W, and I would divide by 2.5, which would give me 480 equals P minus W. Adding these together, I get 1080 equals 2P. My W's again would cancel out. If I divide by 2, I find that 540 equals P. Again, I choose to plug it back into this first equation to find that W must be 60, and I would write a sentence that said the speed of the plane is 540 miles per hour, and the speed of the wind is 60 miles per hour. Try this last one on your own, then press play to see how you did. The light plane is traveling 450 miles, that's distance, equals the rate And the rate is with the wind, so that means the wind is helping it, P plus W, times time, so distance equals rate times time. Flying back, again 450 miles. The speed of the plane working against the wind, it takes 5 hours. Again, I would make this easy on myself by dividing this whole equation by 3, which gives me 150 equals P plus W, and dividing this whole equation by 5, which gives me 90 equals P minus W. When I add these together, I get 240 equals 2P, with W's eliminating. Dividing by 2, I find that 120 equals P, so the plane is moving 120 miles per hour. The speed of the wind can be found by replacing P with 120 and solving the resulting equation to get 30 equals W. So the speed of the plane is 120 miles per hour and the speed of the wind is 30 miles per hour.